Today we worked on 1.3 and 1.4, which is subtraction and multiplication. And I'll come back to this diagram in a moment. And we had just a couple of warm-up problems that, again, these are not meant to be particularly challenging. They are simply meant to give you a bit of a review in the mechanics of subtraction, and then eventually we'll see multiplication. So here's a problem, and I'll recopy it a little larger here. 951 take away 67. You probably recall we had a lengthy conversation about the regrouping that we did when we had an addition problem. Well, we'll use the same concept in accomplishing subtraction, because we immediately, when we start from right to left, we see immediately that I have 7 ones to be subtracted from 1 1, and can't do that. So we remember that here in the tens place, there happen to be 5 tens, which is 50 ones. So easy enough, I will take one of these tens and leave myself 4 tens, and then the 10 that I removed from here, I'll exchange for ones, and then I will suddenly now have not just a single one here, but I'll have 11 ones. And I put the 1 here. I could have doubled up and said now I have 11 ones. And this subtraction I can do. 11 take away 7, 4. Move over. Same issue. Can't take 6 from 4. So we're going to do the same regrouping idea. We have 4 tens. Here are 9 hundreds, 9 100s. So I will take one of the hundreds, and one of those hundreds contains 10 tens. So put it here. 14 take away 6 is 8, and nothing from this 8 is at that. So the answer we get is 884. Again, just as you do these, think about the regrouping activity that's going on associated with your place value of 1, 10s, hundreds. Don't just immediately jump to the calculator. Just take some time and think through these steps and why they're done the way they are. This one, just a very simple one. 52, take away 45, 4, 1, 7, and I'm done. Here was this answer, and here's this answer. And we had a conversation about why is subtraction related to addition. Wait a minute. Why is subtraction related to addition? Because we realize that when I have a subtraction problem, and let's just say we'll call it some amount, take away another amount equals an answer. Oh, and these positions have names: minuend, subtrahend, difference. The reason why this is correct and how it relates to addition, the reason why this answer is C, and I'm going to use some numbers in a moment, is that if I will take the value C and add back the amount that I removed, then I should return to A. So let's do something real simple. Ready? 5 take away 3 is 2. And why is it 2? Because if I take 2 and add back the amount that I removed, I'm now back to where I started. And so this is, you probably recall, this is how we check. This is how we check subtraction. So in this problem here, if I wanted to make sure this was right, I would say 45 plus 7 is 52. So I know I had the correct answer there. Nothing too elaborate. Now, the only last thing I'll mention here is that I kind of went back over my idea of these triangles as memory joggers. And we had one up here, 11 take away 7. 11 take away 7 was 4. 11 take away 4 is 7. 7 plus 4 is 11. So you have to kind of realize I got some equal signs in here. 11 take away 7 is 4. 11 take away 4 is 7. 7 plus 4 is 11. So this idea of capturing some addition and subtraction facts in one place is pretty handy. All right, now 1.4 is multiplication, and if you'll notice the sequence of the work, we do addition, then subtraction, then multiplication, then division. I made the point that actually you could use addition, then multiplication, subtraction, then division. And the reason I say that is because multiplication is repeated addition. How is that? Here's a simple problem. 4 plus 4 plus 4 plus 4 plus 5 plus 5. Now you can add these individually. 4, 8, 12, 16, 5 and 5 is 10, and you get 26. However, since we know about multiplication, we'll say that I have 4 4s and 2 5s, and so I get 16 plus 10 is 26. So I use multiplication to do some addition. It saves us an awful lot of work to use multiplication rather than having to do individual addition. The little problems that we had were these, and we'll do the multiplication, and then I really want to come back maybe and talk about just a minute or two about the details here. Now, think through this with me. This is 7 ones, yes. This is 9 tens. So while we're going to treat this in our multiplication work as a 7 times this and a 9 times that, we've got to remember that the magnitude of the values is different. What does that mean? This means this is 9 tens or 90 ones. So watch how we handle that. 7 times 6, you know what that is? It's 42. 7 times 0, add 4. Why? Because this could only be a 2 because it's restricted in the size of the place value amounts. Remember, we didn't change that. We can still only have, 0 to 9 here. 7 times 6 is 42. The 2 is the ones. Pull these tens over to here. 7 times 0, nothing. Add the 4 that I had from that. 7 times 1 is 7. Now, notice when I begin here, this is not really 9 times 6. Well, it is. We'll count it that way. But this step is really 90 times 6. Now think about that for a minute. 90 times 6. So when I say 9 times 6 is 54, that was really 90 times 6, which is 540. But I will use 9 times 6 as 54 and put a 4 here. Now notice, why did I put the 4 here and not over here? Because think with me again. 90 times 6 is 540. So the 540, 4 tens. So I'll put the 4 here. And 5. 9 times 6 is 54. 9 times 0 is 0. Add 5. And then 9 times 1 is 9. And yes, I have the same restrictions on place values. Now, I left this position vacant because I could make sure I was in the right alignment with place values by putting the result of this multiplication directly under the proper place. Some people like to put a 0 here to placehold, and that's okay. So what's the answer? Add them together now. 2, 8, I think that was a 7, wasn't it? 12, 10. So the answer I got is 10,282, and I'm pretty sure that's the answer. Now, I don't want to belabor this too much, but I want you to just think for a second, what would have happened if I had done this way, right? Now now watch what I'm about to do over here. I'm going to say this is 100, 0, 6. Add that together, I'm going to get 106, right? Now, let's come over here and let's multiply times 7. 7, 7. 7 times 100, 700. 7 times 0, 0. 7 times 6, 42. Add that together, and I should get, boom, 742. Son of a gun, I did. Now, let's do this one, the 97, right? So what do I have here? I have 90, Let's use the same. Let's use 106. Let's do the same. Let's use the method. That's the same method. That'll make it more sensible to us. So we'll do the same thing. We're going to replace 100, 0, 6. Still get 106. And now the multiplier here looks like 9, but it's really 90. So 90 times this, 90 times this, and 90 times this. So 90 times 100 is going to be, I'm running out of room over here, 9,000, 0, and 540. And so when I add those things together, I'm going to get, what am I going to get? I'm going to get 90 times 6 is 540. So I got 90 times this. 90 times this 100 was, what was that? 100 times 90, 009. That was 9,000. I had that right. So when I add this together, I'm going to get what? I'm going to get 9,540. 9,000 plus 540. So the total of that is 9,540. If I take this amount, add it to that amount. Oh, wait, 9,540. Here it is. It's right here. What? Notice the zero's here. And I could have put in a 0, but I had it in the right position because I aligned my tens. Well, you want me to put a 0, I will. When I add this together with this, I've already done it, so I get the right answer over here. Now, this is a use for multiplication, and we can use it to calculate area. And envision this. Envision yourself with 7 positions, 7 this way, and 14 this way. And so what we have is we have a sort of a checkerboard here of squares. And how many little squares would we have? We would have 98 squares. So this is 98 square feet. Why do we call it a square foot? Well, it's not 98 as a distance, as a single distance. It's 98 of these little squares in this pattern. So we use multiplication to calculate area. Oh, and remember, we had those triangles to help us with our addition and subtraction. Well, they will do the same thing with multiplication. And let's just do one here, okay? 7, 4, 28. Instead of adding, I'm going to multiply, and instead of subtracting, I'm going to divide. What? And we're going to do dividing in the next class. But 7 times 4 is 28. 4 times 7 is 28. 28 divided by 7 is 4, and 28 divided by 4 is 7. So when we do division, you'll see that we use these little triangles. We can capture 4 facts, 2 multiplication, and 2 division facts using that triangle technique. Let me see if there's anything else that we did that's worth talking about. I don't think so. Okay, so hope this helps you.